Hi everyone, it's Miss Costa here, and in this video we're going to go through the June 2022 Higher Paper 3. So in this question I am told that here is a right-angled triangle and I'm asked to work out the value of x, which is the length of one of the sides. Now if you're given a right-angled triangle, you know there's two things that you can use. The first thing is Pythagoras and the second would be trigonometry. Now Pythagoras is when we have two sides that have been given and we're trying to work out a third final side of a right angle triangle. So in this case, I know I'm going to use Pythagoras. I don't need to involve trigonometry. So Pythagoras' theorem states that a squared plus b squared equals c squared, where a and b are just the length of the two smaller sides or shorter sides, and a c is the length of the hypotenuse, where the hypotenuse is the side opposite the right angle. Okay, so what I do is I just substitute my values into this formula. Now I've been given the length of the hypotenuse, so therefore I rearrange this equation to be c squared take away a squared equals b squared. And the reason I do that is because Pythagoras was based on essentially if we drew a square around each of the sides. So over here you've got a square of length 4 centimeters, which would be 16 centimeters squared. Here you have a square of length 8.5 centimeters, so the area of that would be 8.5 times 8.5, which is 72.25. And here you have a square with a length x, so you know that area is going to be x squared. Now, however you do this, for any right angle triangle, the area of the two smaller sides, the squares formed by the two smaller sides, will sum to make the area of the largest side, the square formed by the hypotenuse. So I know that 72.25 take away 16 must give me the area of the square over here, x squared. So I can just type that into my calculator and it leaves me with 56.25 equals x squared. So I know the area of this square here is 56.25. The final part is I know x squared is equivalent to 56.25, so I square root both sides to get the value of x by itself. So the square root of my answer is 7.5. And that is how I would work this out. So if Pythagoras is something that you've forgotten about, then be sure to check out the full length video. This is just a quick whistle stop tour. Okay, so here I'm told that t equals 4m squared minus 11, and I need to work out the value of t when m is -3. So essentially I need to substitute -3 into this formula. Now it always helps to actually just write out what the formula is doing. So 4m squared, what does that mean? It means 4 times by m squared and then take 11. It's helpful to do this because sometimes people, I don't know, they substitute the -3 and turn it into -43. So think about what the algebra is doing and then work it out. So 4 times by -3 squared, take 11. I'm just doing it bit by bit. So 4 -3 times -3 is 9, and then you take 11. So 4 times 9 is 36, take 11 is going to leave me with 25. So all you're doing is you're just substituting the value into that. And in the second part of the question, I'm being asked to rearrange the formula to change the subject. So at the moment, d is the subject of the formula. The subject is the variable that is on its own on one side, and I want to make p the subject of the formula. So I'm going to move everything from one side to the other until I am just left with p. So the first thing I'm going to do is subtract 4, because when you're changing something to the subject, you leave the variable that you want at until the very end. Okay, so we're not going to divide by 3 first, because if we divided by 3, we have to divide each part of the formula by 3, and it just becomes a little bit nasty, like you'd be left with 4/3, which is unnecessary. So we always leave that till last, and we move anything that is simple and easy to move. So the inverse of 4 is -4. That would cancel it out from this side because they're a balanced equation. Whatever I do to one side, I have to do to the other. So I'd be left with d take 4 equals 3p. And then the last bit, what does 3p mean? It means 3 is being multiplied by 3. So therefore, to do the inverse, I'm going to have to divide by 3. That would cancel this out on this side. And whatever I do to one side, I have to do to the other. So when you have more than one term being divided, you just write it as a fraction. So you just divide everything by 3 in one go. And then you've got your subject. So p equals d take 4 over 3. Okay, so in this question, I'm told that Rick, Selma and Tony are playing a game with counters. Rick has some counters. Selma has twice as many counters as Rick, and Tony has 6 counters less than Selma. Now, the key vocabulary here is sum, okay? So I know that I have an unknown, and whenever I have an unknown, it's always really helpful to use algebra. So if I start with Rick, Rick has some counters, so I can just call that X. I don't know how many counters he has, but I know that people's counters are spoken about in relation to his. So if I call his X, I can manipulate everything else around that. So Rick has some counters, which we're going to call X. Selma has twice as many counters as Rick. So she has 2 times by whatever Rick has. So that would simplify to 2X. And then Tony has 6 counters less than Selma. So Selma has 2X. And Tony has 6 less than that, so I'm going to subtract 6 from whatever Selma has. In total, they have 54 counters. So therefore, if I add this, plus this, plus this, so x plus 2x minus 6, that must sum to 54. So then I can simplify. So 2x plus 2x is 4 plus 1 is 5x minus 6 equals 54. And then I can just solve this equation to find out what x is. So I add 6 to both sides. So 5x equals 60. And then 60 divided by 5 is 12. So I know that x equals 12. So if x equals 12, I then need to write down the number of counters Rick has to the number of counters Tony has, and I need to write that in the ratio form 1 to p. So let's first work out. So Rick has x counters, so I know that Rick has 12 counters. And Tony, he has 6 counters less than Selma, so his was 2x minus 6. So 2 times 12 is 24. 24 take away 6 is 18. Okay, so Tony has 18 counters. And if I write that in the ratio Rick to Tony, that would be 12 to 18. But they want me to write it in the form 1 to p. So I'm going to put 1 there. And then what have I done to my ratio to get from 12 to 1? I've divided by 12. So I need to do the same thing over here. So I'm going to do 18 divided by 12. Which is 1.5. Therefore, the value of p is 1.5. Okay, so here I'm told that Joe is going to buy 15 rolls of wallpaper and some information about the cost of rolls of wallpaper from 2 different shops. So Chic Decor, I know I could get 3 rolls for £36, and in Style Papers, a pack of 5 rolls is normally £70. But there's a deal going on, which is 12% off the normal price. Joe wants to buy the 15 rolls of wallpaper as cheaply as possible. Should she buy them from Chic Decor or from Style Papers? So here is where I need to essentially work out which is the best buy. So where is my where am I going to get the best value for money? So she wants to buy 15 rolls. And I know that at Chic Decor, she gets 3 rolls for £36. Okay, so 3 rolls is £36. I want 15 rolls. So what have I done to get from 3 to 15? I've multiplied that by 5. So I can do 36 times by 5, which is 120. So I know that at Chic Decor, it's going to cost £180 for 15 rolls. Now I need to figure out how much it would be at Style Papers. So a pack of 5 rolls would normally be £70. However, there is 12% off. So when there's a discount, you can either work out 12% and subtract it from 70, or use the percentage multiplier. So I know that 100% take 12% is going to leave me with 88%. So I know my percentage multiplier would be 0.88. So if I did 70 times 0.88, that would be £61.60. So I know that for 5 rolls, it's going to cost me £61.60, but I want 15 rolls. So what have I done to get from 5 to 15? I've multiplied by 3, it's 3 times as much. So I have to do the same to this side. And that would give me £184.80. Okay, so at Style Papers, it's £184.80 for 15 rolls. At Chic Decor, it is £180. So she should buy it from Chic Decor, as it is £4.80 cheaper. Okay, so whenever they ask you where they should buy it from or anything, you have to actually say where they should buy it from, and also just give a reason, because it's cheaper. So here I have been given a frequency polygon. I've been given a table that gives information about the lengths of some pieces of string, and then Amos has drawn a frequency polygon for this information. And I need to write down 2 mistakes that Amos has made. Well, the most important thing about a frequency polygon, or one of the most important things, is that you always plot against the midpoint of the class interval. So let's check that he has done that. So this should be, the coordinates should be 5, 15, 15, 20, 25, 50, 35, 25, and 45, 5. So let's check he's done that. 5, 15, yep. 15, 20, 25, 50, 35, 25, and then 45, 5 is where this coordinate should be. So the graph should look like this. So one mistake is he hasn't plotted the final coordinate using the midpoint. It should be 45, 5, not 55. And then what else? Okay, so let's have a look at what else is going on. So it's called frequency. And then let's look at the scales. Usually there's something with a scale. So it's going up in 10, 20, 30. Okay, so this here should be 40 if it's going up in tens. Your scale always has to go up in a consistent amount. So the y-axis does not go up consistently. He skipped 40 by accident, I'm assuming. And those would be the mistakes that he's made. Okay, so here I'm told that Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs, and I need to work out Amy's average speed. Okay, so what do I know? Well, my formula for speed is speed equals distance over time. So let's see what I can figure out from the information I've been given. So I know she runs for 15 minutes at an average speed of 6 miles per hour. Now, what's really important is when we're dealing with speed, we generally, unless it's an exceptional question, we deal with time in terms of hours. So I want to convert 15 minutes into a fraction of an hour. So how do I do that? Well, there's 60 minutes in an hour. So that becomes 15 over 60, which would simplify to a quarter, which is 0.25. Now you could leave it in terms of a fraction if you wanted to. You could have just said a quarter of an hour, or you can write it as a decimal. So I know that she runs 0.25 hours at an average speed of 6 miles per hour. So using the formula where speed equals distance over time, I'm going to substitute what I know. So I know that her speed is 6 miles per hour. I don't know the distance, that's what I'm trying to find out. And I know the time is 0.25. So to work out the distance, I'm going to do 6 times by 0.25. I just multiply both sides by 0.25 in order to get the distance as the formula. So 6 times by 0.25 is 3 over 2. So the distance is 1.5 miles. Okay, so then I can do the same for the next part. So she runs for 40 minutes. So let's work out what 40 minutes is first. So 40 over 60. I can just type that into my calculator because this is a calculator question. Would give me, well, I can leave that as a fraction because otherwise it's going to be 0.6 recurring, whichever you feel more comfortable with, at an average speed of 9 miles per hour. So her speed, 9, is the distance, which I'm trying to find out, divided by 0.6 or recurring. Be very careful. If it says 0.6 recurring, you have to enter 0.6 recurring into your calculator. So to work out the distance, I would do 9 times by 0.6 recurring. So the distance is 6. If you didn't get 6, then you didn't type in the 0.6 recurring. You could also leave it as a fraction. So I know that the distance over here is 6 miles. And that means that in total, Jessica ran 6. So Jessica's total distance is 6 plus 1.5, which is 7.5 miles. If I know that Jessica ran this, I'm told that Amy takes 45 minutes to run the same total distance. So let's substitute into the formula again. I'm trying to work out Amy's speed. I know that her total distance is 7.5 miles. And I know that she ran 45 minutes. Now you might know that 45 minutes is 3/4 of an hour. If you didn't, you just type in 45 over 60, which gives you 3/4, which is 0.75. So I know that her speed is going to be 7.5 divided by 0.75, which is 10 miles per hour. Okay, so in here I'm given a slightly complicated looking diagram. I'm told the diagram shows a rectangle STUV. So it's a rectangle, so I know that all sides, opposite sides, are going to be equal. TQU, so TQU over here, and SRV are straight lines. All measurements are in centimetres, and I know the area of trapezium QUVR, so this trapezium here, is A centimetres, and I need to show that the area of that trapezium is 2x squared plus 20x. Okay, so essentially you're trying to figure out what the area, an expression for the area of this trapezium would be. So what do we need to do? For a trapezium, the area of the trapezium, you work out by knowing what the two parallel sides are. So you do A plus B times by the height divided by 2. So all I need to figure out is the length of A and B, which is the two parallel sides over here, times it by the height, which I know over here because it's 4x on the other side, and then divide it by 2. So I know that if I call this A and this B, just because it's the shorter side, I know that A equals 5 because it's a given. I then need to work out what B equals. So I know that this whole length here is 3x plus 5. I know this length here is 2x. So 3x plus 5, take away 2x, must leave me with this bit here, QU. So 3x plus 5, take away 2x, leaves you with x plus 5 must be the length of QU. So B must be x plus 5. Now there's loads of different ways you could write the area of a trapezium. You could write half A plus B times height. There's loads of different ways. You use whichever formula you feel most comfortable with. But let's see what we do next. So I know the value of A, I know the value of B, and I know the value of the height, which is 4x. So all I need to do is substitute into the formula. So A plus B would be 5 plus x plus 5. And then I multiply that by 4x, and then I divide everything by 2. So let's simplify that. That would become 10 plus x multiplied by 4x. I can just write it like that in a bracket, divided by 2. So if I expand my brackets out, that would become 40x plus 4x squared, all divided by 2. What's 40 divided by 2? That's 20x, and 4x squared divided by 2 would be 2x squared. Therefore, the area of the trapezium must be 2x squared plus 20x. All I've done is change them over. So here I've got a conversion graph. I'm told that an electricity company charges the same fixed amount for each unit of electricity used. David uses this graph to work out the total cost of electricity he has used. Okay, so I know that this graph is in direct proportion because it's the same fixed amount for each unit. So work out the gradient of the straight line. Well, how do we work out the gradient? The gradient is the change in the y coordinates over the change in the x coordinates. So let's find okay, and this is where people frequently go wrong with gradient. You just want to pick a part where the line goes through. So if this is a square, one of the little squares, you want to make sure the line goes exactly through the corner of the square, otherwise you're going to be getting estimates and whatnot. So let's find a part where the line goes exactly through the square. Oh, over here. So I've covered it, but you should have it on your paper. So over here is the coordinate 100, and then let's figure out what this is. So the x coordinate is 100, the y coordinate, okay, I know the gap over here is between 12 and 16 is 4. I know there are 1, 2, 3, 4, 5, 10 squares. So 4 divided by 10 is going to give me 2/5, which is 0.4. So that means that each little square is 0.4. So this is halfway through that. So 0.4 times 5 is going to give me 2. So therefore I know that coordinate over here must be 14. Okay, so that would be 114. And then I could just go straight to 0 because it's in direct proportion. So I'm going to work out the change in y, which is 14, and divide that by the change in x. So 100 to 0 is 100. So the gradient is 14 over 100, which is, so 14 divided by 100 would give me 0.14. So the gradient of the straight line is 0.14. And then I'm asked, what does the gradient of this line represent? So the gradient, so if I think about it logically, I'm dividing £14 by 100 units. So that's what I'm actually doing. So therefore the gradient, if I divide £14 by 100 units, I figure out that 0.14 is the cost per unit. Okay, so the gradient of the line represents the cost per unit. Okay, so each unit costs 14 pence, and that is what the gradient is telling me. Think about it like contextually, you know, the y-axis is the cost, the x-axis is the number of units used. So £14 divided by 100 would tell you how much 1 unit is costs. Okay, so here we've got a slightly complicated looking indice, but if we just break things down bit by bit, applying all of the things that we know, we can go through this question. So the first thing that I probably want to do is think back to my index laws. So I know that when I'm multiplying indices, I just add the powers. So if I had a to the power of m times a to the power of n, I would end up adding the 2 powers. So using that, I can simplify the denominator. So 10 to the power of 150 times by 10 to the power of 90 must equal 10 to the power of 150 plus 90, which is 10 to the power of 240. So I can rewrite this as the square root of 10 to the power of 360 over 10 to the power of 240. Next thing I could do is use my next index law. Over here, I'm dividing the indices. So when I divide indices, what do? I subtract the powers. So I could write 10 to the power of 360 divided by 10 to the power of 240 must equal 10 to the power of 360 take 240, which is 10 to the power of 120. So I can rewrite this as 10 to the power of 120. And the final bit, and this is where it gets into the higher powers. So whenever you've got something written as the square root, when I have the square root of any number, I can rewrite that as a to the power of a half. So therefore, I could rewrite this as 10 to the power of 120 to the power of a half, because the whole thing, everything inside the square root is being square rooted, so it's all to the power of a half. And what do I do when I've got indices in brackets? Well, a to the power of m to the power of n, I just multiply the indices together. So I'm going to do 10 to the power of 120 times by 0.5. You can leave it as a half if you want. I just root it as 0.5. Becomes 120 times by 0.5. Timing by 0.5 is the same as dividing by 2. So that would become 10 to the power of 60. Because 120 times 0.5 is 60. And you've just expressed that as a power of 10. So you've worked out each tiny little bit that takes you one step closer to working out the final bit. Okay, so over here, I'm told that Liam was asked to express 12 to the power of 50 to the power of 2 as a power of 12. Liam wrote 12 to the power of 50 times 2 equals 12 to the power of 50 squared. Okay, so what did he do wrong? Well, Liam did 50 squared. Don't know why he did that. When you are multiplying indices in brackets, you multiply the powers. Whereas he squared them. He did 50 squared. So his method is wrong. What should it have been? Well, 12 to the power of 50 to the power of 2. What do? I multiply the indices, so that should have become 12 to the power of 100. Okay, so what did he do wrong? Instead of multiplying 50 by 2, he did 50 to the power of 2. Okay, so I'm told that Jane bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 12.5%. The value of the car then decreased by 10% each year for the next 2 years. At the end of the 3 years, the value of the car was £17,010, and I need to work out the value of the car when Jane bought it 3 years ago. So, okay, I have an unknown. Whenever I have an unknown, I can just call it X. So X, which is the value of the car, the original value, was multiplied by, so this is where I need to think about my percentage multipliers. So the value decreased by 12.5%. So 100, take away 12.5, leaves you with 87.5. Okay, so I'm technically working at 87.5% of it. As a multiplier, that would be 0.875, because what does percentage mean? Percentage means out of 100, which is the same as dividing by 100. So 87.5 divided by 100 gives you 0.875. So my first multiplier would be 0.875. The value of the car then decreased by 10% each year. So once again, 100 take away 10 is 90. So 90% is what I'm trying to work out of the new value. And what does percent mean? Divided by 100. So 90 divided by 100 gives you 0.9. So that's my multiplier for the next 2 years. So I'm going to multiply that by 0.9 and then by 0.9 again. And that gives me my final value of £17,010. So what I can do is simplify all of this. So bring this all together. So 0.875 times by 0.9 times by 0.9 gives me 0.70875x must equal £17,010. So to work out what x is, I'm just going to divide by 0.70875. So divide both sides by this, because what is happening when a number and a letter are next to each other, it means they're being multiplied. Okay, so I divide by 0.7875 on both sides. So 17,010 divided by 0.70875 equals 24,000. So therefore, the value of the car when Jane bought it must be £24,000. So all I'm doing is I work out, whenever you're doing compound appreciation or depreciation or interest, work out the multiplier. And then in this question, we're working backwards. So whatever my original amount is, I would have multiplied it by this, then this, then this, and my final result is this. So I'm just working backwards to work out what the original amount is. Okay, so in this question, I'm being told that Raheem has 16 shirts, 5 pairs of jeans, and 3 jackets. And Raheem chooses an outfit to wear, which is 1 shirt, 1 pair of jeans, and 1 jacket. And I need to work out how many different outfits Raheem can choose, i.e. how many different combinations I can do. And with a combinations question, all I do, if you think about this logically, you've got 16 shirts. So let's imagine I've got 16 of these drawn. Okay, so you've got 16 shirts and you can combine them with 5 pairs of jeans. Okay, so I'm just going to write 16 here. Imagine I've drawn 16 shirts. I could combine them with 5 pairs of jeans. So therefore, shirt 1 I can combine with jeans 1, jeans 2, jeans 3, jeans 4, jeans 5. Shirt 2 I could combine with jeans 1, jeans 2, jeans 3, jeans 4, jeans 5. That's why I'm multiplying. Okay, so if I had 1 shirt, I would multiply it by 5 because there's 5 options. But I have 16 shirts, so I'll multiply it by 5 because each shirt can be combined with 5 different jeans. And then 3 jackets. How am I going to draw a jacket? I don't know, like that. Okay, so I've got 3 jackets that I can combine it with. So each thing, essentially when I'm doing combinations, I'm multiplying everything by itself. So 16 times 5 times 3 would give me 16 times 5 times 3 is 214. Okay, so whenever you've got a combinations question, which is how many different ways can you combine things like outfits or salad dressings or things, you multiply all of your options together. Okay, so here I'm told that ABC and ACD are right-angled triangles, and that's important because with any right-angled triangle, I know that I can either use Pythagoras or trigonometry. So these 2 things should always come to mind when you are told about a right-angled triangle. Now I'm told that the length of DC over here is 8 centimeters, angle ADC is 45, and angle ABC is 20, and I need to work out the length of AB. So AB is this length here. Okay, so what can I do? Well, generally with questions like this where you have 2 triangles put together, you're going to start with a triangle that does not have your desired outcome. So triangle ACD is a triangle whose length I want to work out. So most likely I'm going to start working out something from this triangle. So I know I can use trigonometry or Pythagoras, but Pythagoras is only when I've got two sides, so I know it's going to be trigonometry. And I know I've been given this angle here and this length here. So I can start by labeling my triangle. The first thing you should always do with trigonometry is label your triangle. So here's your given angle, and everything, each side is labeled according to that given angle. So this is going to be the opposite because it is opposite the given angle. This side is going to be the adjacent because it is adjacent, it is next to your angle. And this is going to be the hypotenuse because it's the angle, it's the side that is opposite the right angle. That's always going to be the hypotenuse. So let's write out our SOHCAHTOA just to help us remember which ratios we're going to use. So I've been given the adjacent and which side, okay, so let's think about this. Which side do you think it would be most beneficial to use? Well, if I figured out what this length here is, then I would be able to use trigonometry to figure out the length of AB. So the sides I'm going to use are the opposite, and also I've been given 8 centimeters, which is the adjacent. So O and A, I'm going to use tan. So I say tan theta, I'm just going to write out the formula. Tan theta is the opposite over the adjacent. So theta represents, so this little thing just represents the angle. So tan 45 equals opposite. The opposite side is what I'm trying to find out. So let's call that X over the adjacent, which is 8. So then I just rearrange this formula, multiply both sides by 8. So 8 tan 45 equals X. So let's type that into my calculator. 8 tan 45 equals 8. Okay. So I know that the length of AC is 8, which is nice and handy because it's not a complicated decimal. So let's then have a look at this triangle here. So I've got my given angle of 20 degrees, a length of 8, and my right angle is over here. So once again, let's label it. So this is my angle, this would be the adjacent, this would be the opposite side, and this would be the hypotenuse. And what am I trying to work out? Well, I'm trying to work out the hypotenuse because that's the length AB, and I've been given the opposite. So once again, if I've got SOHCAHTOA, what do I do? Well, I've been given O and H, which is sine. So I'm going to write out sine theta equals opposite over adjacent. So sine 20 equals 8 over, hold on. Sorry, that's supposed to say hypotenuse. 8 over hypotenuse, and I'll just call that X because that's what I'm trying to figure out. Now, this is where a lot of people get really confused. So you're trying to rearrange the subject. So the proper way is you'd multiply it. So that would become X sine 20 equals 8, and then you'd divide by sine 20. Okay, so that would be 8 over sine 20. But the shortcut way is if you've got you're wanting to make X the subject and you've got something else on the other side and X is on the denominator, you can just flip them. So that could become X equals 8 over sine 20. The reason you do that is over here, but a lot of people get confused by that. So if it's easier for you to sort of grasp it, then just know that you flip them. If you're trying to make the subject and it's the denominator. So you flip them, so therefore X must equal 8 over sine 20, which is 23.3904352, and it says give your answer to 3 significant figures, so that would be 23.4. Okay, so here I've got some vector arithmetic that I need to do. So I'm told that A and B are vectors such that A is 2, -3, and B is 3, 8, 8, 2B is 8, -17. So, and I want to find B as a column vector. So I know that A is 2, -3, and I know that over here I can compare it to 3A take away 2B. So first of all, if I figure out what 3A is, that's going to help me. Now, when I'm doing that, when you're doing vector arithmetic, whatever you can manipulate the vectors to turn A into 3A. What have you done? You've times it by 3. So you multiply each part of the vector by 3. So 2 times 3 is 6. Negative 3 times 3 is negative 9. So I know that 3A is 6, negative 9. So now I can substitute that into the vector. So I know that 3A take 2B equals 8 minus 17. So 6 minus 9 take 2B equals 8 negative 17. Now, just like if it was algebra, so if I had, let's say 3A take 2B equals x, I could rearrange it to make negative 2B the subject. So what would I do? I would subtract 3A from both sides. So similarly, I'm going to do that except with vectors. So minus 2B equals 8 minus 17, take away 6, negative 9. So let's have a look at that. 8 take away 6. So when you're subtracting vectors, you subtract the x values and the y values separately. So 8 take away 6 gives me 2. And minus 17 minus 9 is going to give me minus 17 plus 9. So that would give me negative 8. So I know that negative 2b is 2 negative 8. So let's see what I can do then. If I know that negative 2b is 2 minus 8, I'm being asked to find b as a column vector. So let's divide it by 2. So b would be 1, negative 4. Sorry, negative b would be 1, negative 4. Now what I want to do is multiply by negative 1 on both sides, i.e. flip everything, because I don't want negative b as my subject, I want b as my subject. So b would be negative 1, 4. And that's how I'd do that. Okay, so here I'm being asked to factorise fully. Okay, now when I'm factorising, what I'm doing is I'm putting things into brackets, but what you're trying to do is you're trying to extract or squeeze as much as you can and put it outside the bracket. So as much as possible is outside of the bracket. So a common thing that people would do with a question like this is they think, oh, this is the difference of 2 squares. So therefore I could just factorise it as 2p plus 6, 2p minus 6. And yes, you could, but that's not factorising it fully. So we just need to be really careful if we've got something that is not quite so simple. So if it was p squared minus 36, yeah, it would just be p plus 6, p minus 6. But we've got a coefficient to p squared. So the first thing we want to do is factorise that out. So if I factorise that out, I'd be left with 4p squared minus, and 36 divided by 4 is 9. Okay, so I've factorised that so that I still have my difference of 2 squares over here, but I've factorised out as much as I can to begin with. So then I can factorise the difference of 2 squares. So it'd be p plus 3, p minus 3. Okay, so this is a lot more factorised than saying 2p plus 6, 2p minus 6, because when you're factorising, you want to extract as much as you can and put it out of the bracket. Okay, so that is the best way to do this. When you're factorising fully and there's a coefficient in front of it, you can do it this way. So factorised fully would be 4p plus 3, p minus 3. And the difference of 2 squares, if you've forgotten, then just make sure you look it up. But really briefly, it just means that if you've got x squared, take away y squared, then when you factorise it, it would be x plus y, x minus y. Okay, so here we've got to show that question. So I'm being asked to show that these 3 brackets can be written in the form am cubed plus bm squared plus cm plus d, where a, b and c are integers. Remember, integer just literally means a whole number. So a lot of people get freaked out when they see the word integer because they've forgotten what it means. It just means whole number. So with a show that question, you want to show you're working meticulously and each tiny little step make it super clear. So what I can do is just expand my brackets. So the first bracket, I've got m plus 4 and 2m take 5. So I'm going to do m times 2m would give me 2m squared, sorry, and then m times negative 5 is minus 5m. 4 times m is 8m, and 4 times negative 5 is minus 20. Okay, so you bring that together, 2m squared, 8 take away 5 is 3 minus 20. So you know that your first two brackets expand to make this. Now there's loads of ways you can do it. Normally I say use the grid method way, and in fact I'm going to stick by that because so many people just make silly mistakes because they're rushing. So I'll show you how to do the grid method way. So I know that these two brackets expand to make this. Okay, so then I draw myself out a grid with 3 terms by 2 terms. I write this expanded bracket, so 2m squared, 3m minus 20, and I'm going to multiply it by my final bracket, 3m plus 1. If you're super confident with multiplying out brackets, then you could have just done that like that, and that's fine, but using the grid method just ensures that you don't forget any terms out by accident. So let's have a go. 2m squared times by 3m is going to give you 6m cubed. 3m times 3m is going to be 9m squared. Minus 20 times 3 is minus 60m. Then 2m squared times 1 is just itself. 3m times 1 is just itself. And negative 20 times 1 is also just itself. Now the cool thing about doing it this way is that generally your diagonals are going to always simplify. So if we write all of this out, we've got 6m cubed. And then I know these are going to simplify. So 2 plus 9 is 11m squared. Minus 60 plus 3 is going to be minus 57m, and you're going to be left with minus 20. So has that been written in the form am cubed plus bm squared plus cm plus d? Yes. Is everything an integer? Yes. So that is how you have shown that a, b, c and d are integers. If you did it this way, you just would have shown it by doing this. So 6m cubed plus 2m squared and so forth. But as you can see, when you do it in the grid, you can just simplify it a lot easier and quicker. So that's that. Okay, in this question, I am told that P, Q, R and S are 4 points on a circle, and that I have P, X, R and S, X, Q are straight lines. So these two lines here are straight. Prove that triangle PQX and SRX are similar. Okay, so in order to prove similarity, I have 3 options. The conditions of similarity are that all 3 angles are equal, all 3 corresponding angles are equal, and this is generally proved by just proving that 2 angles are equal, because if 2 angles are equal, the third must be equal because angles in a triangle sum to 180. Or a side, an angle, and a corresponding side are equal, so the side, the angle and the side and the same corresponding set in the other triangle, or by all 3 sides are equal. So I mean, I'm going to have a guess and say that the best option from this is going to be proving our angles, but let's have a look. So I was told that these 2 lines here are straight lines. If they are straight lines, then you have over here vertically opposite angles. So if you've forgotten about this, then vertically opposite angles are equal. And they are formed by 2 straight lines crossing. So they look like a cross like this, and we know that they are equal. So therefore I know that angle QXP must equal angle RXS as vertically opposite angles are equal. So usually, well, you're proving it. So if you're going to prove something, you must state your reasons. You have to. If you don't state your reasons, I'll be like, well, okay, how do you know? So I know that this angle is equal to this one because vertically opposite angles are equal. That's just a basic angle fact. So hopefully, even if you're not 100% on your circle theorems, you recognize that. Then what I can do is I'm going to look. I know that I've got 2 angles that are at the circumference. Okay, so over here, this circle theorem is angles at the circumference subtended by the same arc are equal. This is also sometimes known as the angles in the same segment. I prefer the first because it just makes more sense, because you can visually see where the arc is formed, but you use whichever one you're more familiar with, especially if you recognized it as a segment rule. So just a quick reminder, subtended just means created or formed. Okay, so it's saying angles at the circumference that are formed by the same arc are equal. And how do you demonstrate that? Well, let's use a different color. So over here, I've got an angle here, this angle. So I've got angle PQX, okay? And let's have a look at what arc creates this. So follow the lines along and you shade the arc in. So this angle here, if I extended it, keep on extending, it's formed by this arc here, okay? So I know that that is formed by that arc, and then I can do the same for the next angle here at the circumference. This angle here, if I followed it along, what arc is it formed by? Well, it's formed by the same arc, this arc here, okay? So therefore, that circle theorem proves that those two angles are equal. So angle PQX must equal angle PR. Oh, and I've lost what this letter is. I think it's S. Is it S? Let's just check. Yeah, S. Oh, still PRS as angles at the circumference, and I'm not going to write out the circle theorem again because I wrote it out here, but this one here, okay? So as angles at the circumference subtended or created by the same arc are equal. The next thing I need to do is prove my next angles are equal. So let's have a look over here, what's going on. It looks like I've got angles at the circumference again. So let's just double check if this is true. Well, if I extend the arc, if I extend the angle, it's formed by this arc here. If I do the same to this angle, once again, it's created by this arc here. So I could say angle QPX must equal angle QSR as angles at the circumference subtended by the same arc are equal, and that's absolutely fine. Or you could say must equal angle QSR as angles in a triangle sum to 180 degrees. And obviously if you've got two angles that are equal, you have the same amount that is going to be left over for the missing angle. So you can choose whichever works best for you. And if you've proven that three angles are equal, so the last step, you'd say AAA, all three angles in both triangles are equal, therefore the triangles are similar. Okay, so over here we've got a bounds question. We're told that P equals the square root of 2e over f. The value of e is 6.8 correct to one decimal place, and f is 0.05 to one significant figure. We need to work out the upper bound for the value of P, and then give our answer to three significant figures. So the key thing with bounds, a lot of people, you can memorize how to work out the upper bound and the lower bound when you're using division and things like that. But if memorization isn't your key suit, then what you can do is just substitute numbers in to see what would work. So for instance, if you said that E was 5 and F was 2, and then reverse that, we could see which would give us the bigger answer. So let's say P would be the square root of 10 over 2, so P would be the square root of 5, okay? Or if we reversed that, P would be 4 over 5, or P would be the square root of 0.8. Okay, now the square root of 5 is going to be larger than the square root of 8, so therefore to work out the upper bound of P, I'm going to want the upper bound, so the greatest value of E and the lowest value of F. So let's just work that away. So to work out the upper bound with the division, you want the greatest value as your top numerator over the lowest value. And if this still confuses you, then what you can do, it's not going to be very time efficient, but what you can do is work out all 4 possibilities and then give your final answer as the upper bound. So let's have a look at E. 6.8 correct to 1 decimal place. Okay, so if it was 6.9 or 6.7, it would have rounded down. So therefore the bound within which it lies, the lowest value it could be is 6.75, and the largest possible value it could be is 6.85. Now obviously we know that it's not 6.85, we just use this for bounds, it's fine. So it would technically be 6.849 recurring, but instead of doing that, we just say, okay, we're going to say it's 6.85. So E is 6.85 to the upper bound. And then let's have a look at F. F is 0.05 correct to 1 significant figure. So to 1 significant figure, it would be 0.06 or 0.04. So once again, let's look at its bounds. The upper bound would be 0.055 and 0.045. So you basically say, when you're doing bounds, you think, what are the options for it to round up or down to, and then you find the midpoint. So for F, the lower bound is 0.045 for the lower bound. Okay, I don't need the other values because I already know that to find the greatest value for P, I need to do the upper bound divided by the lower bound. But once again, if you're not 100% confident, just do all of them if you have extra time and if this isn't your strong suit. So now I need to just enter these in. So P is going to equal the square root of 2E, so 2 times 6.85 over 0.045. So I've got a calculator, so let's just enter that in. That would be 2 times 6.85 over 0.045, and my final answer is 17.44833,644, and it says give your answer correct to 3 significant figures, so P would be 17.4. Circle the third digit, I look next door. If the answer is 4 or less, just ignore it, leave it as is. If it's 5 or more, I round up. So P is 17.4. Okay, so in this question, I'm told, I'm given a frequency table, and the table gives information about the distances in miles that some year 10 students live from school. And I'm being asked to draw a histogram for this information. So I'm being given a frequency table, which essentially tells me, in this case, that 90 people walk between 0 and 1 miles to school. So frequency just means the number of students or the number of whatever it is in the question you're given. In this case, it's students. So I know that 90 students walk between 0 and 1 miles. Now, the key things that we need to know is that on a frequency, on a histogram, the frequency is represented by the area of your bar. So therefore, to work out the frequency density, we do the frequency divided by the class width. Okay, so they're the key things that you should always remember and think back to when doing histograms. Now you can see that we haven't been given a frequency density value, so therefore we're going to need to work that out. So how do we work out the frequency density? Well, we do frequency, so 90, divided by class width. So the difference between 0 and 1 is 1. So therefore, the frequency density for my first one is going to be 90. So I know that on this scale, I'm going to need to have something that goes up to 90. 90 is, so let's have a look. So I've got 1, 2, 3, 4, 5, 6 big squares. So if I divided that by 2, that gives me 12 little squares, which means I could go up to 90. So I could say that each little block of 5 represents 10. So that would be 10, 20, 30, 40, 50, 60, 70, 80, 90, and then carry it on. So for my first bar, I go up to 90 and down to 1. And then what is the area of this? Well, 90 times by 1 gives me 90. So I know that's right. For the next one, to work out, sorry, this should have said frequency density. For the next one, to work out the frequency density, I'm going to do 48 divided by 0.5. So 48 divided by 0.5 is the same as just multiplying 48 by 2, which is 96. So I know that between 1 and 1.5, I need to go to 96. This is going to be a little bit more challenging. So I've got 10 represents 5 squares. So therefore 10 divided by 5 is 2. So each little square is 2. So 2, 4, 6 would be 96. And then that would be my second bar. So remember, the bar is always going to be the width of your class interval. That's how wide your bar is, and the frequency density is whatever the frequency is divided by the class width. So then you've got the frequency density for the next part. So you've got 22 divided by 0.5 again. And remember, when you divide by 0.5, it's the same as timesing by 2. So that would be 44. So I've got 44. So that's 2, 4 over here. And once again, it's just the width of 0.5. Then you've got 2 to 3 and a frequency of 8. So I'm just going to shorten this to FD for frequency density. I do the frequency divided by the class width, which is 1. So the frequency density is 8. And I go from 2 to 3, and I go across like this to 8. Okay. And for the last one, I've got frequency density would be 12 divided by 2 because the class width is 2. 12 divided by 2 is 6. So this one's going to be 2, 4, 6. It's going to look like this. Okay. And that's how I would draw my frequency, my histogram. So remember, the frequency is represented by the area of the bar. So you can quickly work out the area by thinking, okay, frequency density is 6, class width is 2, 6 times 2 is 12. Okay, so here we've got another histogram question, slightly trickier this time. But if we just apply all of the information we know about histograms, it's quite easy. So the histogram below shows information about the distances in miles that some year 11 students travel from school. And I know that the number of year 11 students who live between 1 and 2 miles from school is n. And I need to find an expression. So I know that I'm only dealing with algebra. I'm not going to need to find a final value. In terms of n for the number of year 11 students who live between 3 and 5 miles from the school. Okay, so the key piece of information I've been given is that the number of students, so the frequency of year 11 students who live between 1 and 2 miles is n. Okay, so I know that the area of that is n. And remember, frequency is going to be your class width times by the frequency density. So therefore, n times by 1 gives me n. So the frequency density must be n because the class width is 1. So n times 1 gives me n. So I know that that is the frequency density over here. The other way I could have done it is frequency density is frequency divided by class width. So I could have just done frequency density is n over 1, which is also n. So whichever you're more comfortable with. So I know that the frequency density is n. I don't need to worry about numbers. I just need to worry about comparing it to n. Now, I know that there's 3 lots of 5 squares in between that. So in total, there's 15 tiny little squares. So I know that each little square must be n over 15. Okay, so each little square here must be n over 15. I could also have split it into like, this must be 2/3 n, this must be n over 3. But what I'm interested in is the tiny little squares. So it's always just best to go for the little squares because then you can work backwards from there. So I know that each little square, I'll just write it over here as well, must be n over 15. And I am trying to work out an expression for this part here. So the frequency density is 3 squares up. So the frequency density of this bar must be 3 lots of n over 15, which would be 3n over 15. I could simplify that just to make my life easier. It's always easy to work with simplified fractions, but you have a calculator, so it doesn't really matter, but I'm going to. So that would just be n over 5 because you divide both top and bottom by 3. So the frequency density of my desired bar is n over 5. So I know the height is n over 5. I know that the class width is 2 because the difference between 3 and 5 is 2. So to work out the frequency of that, so the amount of students, I'm just going to do n over 5 times by 2, which is 2n over 5. So the frequency density, so the number of year 11 students is 2n over 5, which I could write as a decimal if I wanted to. So 2/5 is 0.4, so you could just write it as 0.4n. And that's how you find the expression. So all I'm doing is I'm still using the exact same formula, it's just I'm using and incorporating algebra as well. Okay, so here I have got a slightly complex looking problem. Now, just looking at this, you know that you're most likely going to be using 3D trigonometry because it's a 3D solid and it's looking a little bit complicated. But even if this question freaks you out, hopefully by the end of it, you'll see how there's just little tiny steps that you can take to get you there. So I'm told that here is a prism. And the base ABCD of the prism is a square of side 14 centimeters. Now that means that each of these sides are going to be 14 centimeters, so that is going to be useful information for later on. I'm then told that T is the point on BC, so I can draw out BC over here, which is 14 centimeters, such that BT to TC is in the ratio 4:3. So BT is 4 parts, and TC is 3 parts. So I know that 14 is split into the ratio 4:3, so I do 14 divided by 7 to figure out how much 1 part is worth. So each of these little parts are worth 2. Therefore, BT is 8 centimeters because I do 2 times 4, and TC is 6 centimeters because I do 2 times 3. So now I have 2 new lengths that I know. BT is 8 centimeters and TC is 6 centimeters. So over here, I can label that accordingly. Now, next I'm told that the cross section of the prism is in the shape of a trapezium, area 147 centimeters squared. In case you've forgotten what a cross section is, it's generally the bit at the front of the shape. So in this case, it's over here, and it's called a cross section because imagine you had a cake in this shape. If you sliced it, each slice would be in the shape of this cross section, or you can imagine the cross section as it's the shape that if you pushed through the rest of the shape, it would remain constant. The shape is going to remain the same. So that's the cross section, and I know it's in the shape of a trapezium. Now, what's the area for the formula of a trapezium? Well, there's quite a few ways you could write it, but I like saying a plus b times by the height divided by 2. So that's how you work out the area of a trapezium. If you prefer the other ways, like a half a plus bh, you do whatever you prefer, but this is what I like. So I want to think about all of the sides that I know. Now I know, first of all, I know that A and B are the two parallel sides. So I know that this is going to be A and this is going to be B because they are the ones that are parallel, they never meet. Therefore, the height has to be the line connecting the two parallel sides. So that's h over there. So I know the value of h is 14 because I'm told it here. I know that this length, QB, must be equal to this length as they are on the same solid. So that must be 12 centimeters, and I don't know what A is. So I could substitute my values in. A plus 12 times by 14 divided by 2 must equal 147 because I'm told that area over here. Now all I need to do is rearrange it to make A the subject of the formula to figure out what that missing length is. So A plus 12 times by 14 must equal, if I times both sides by 2, 147 times by 2 gives me 294. Next step, I can divide both sides by 14. So A plus 12 must equal 294 divided by 14, which is 21. The last step is I can subtract 12 from both sides, so A must be 9. So I know that PA is 9 centimeters, this length here. Okay, right, now let's get on to the question. So I am being asked to find the size of the angle between the line ST, okay, so the line ST and the base ABCD. So ABCD is the base, so I can just create a right angled triangle over here. So I know that it's a right angle. I don't know the length of DT. I know that the length of SD must be 9 centimeters because it's equal to this length here. And I don't know the length of ST either. But what can I do? Well, I could create a little triangle over here. This will also be a right angled triangle on the base of the square. So over here, if I draw this out, I've got the height over here is 6 centimeters. This length here would be 14 centimeters because it's the base of the square. I already worked that out. And this length here would be DT. So using Pythagoras Theorem, I know a squared plus b squared equals c squared. So 6 squared plus 14 squared must equal dt squared. So 6 squared plus 14 squared gives me 232 is dt squared. So the length of dt must be the square root of 232, which is 2 to the, so that's 15.23154621. Okay, so this length here is 15.23. So now coming back to the main triangle, I know that this length here is 9 centimeters. This length I've worked out to be 15.23. And I don't know what this length is, that's the hypotenuse, and I'm trying to work out this angle here. So you're trying to work out the size of the angle between the line ST and the base ACD, so this angle here. I'll just get rid of everything else that we did here. So what can I do? Well, I can use trigonometry to help me out. So it's a right angle triangle. So I'll write out my trigonometric ratios, SOHCAHTOA. What am I trying to find out? I'm trying to work out this angle. So let's label the triangle accordingly. This is adjacent because it's adjacent to the given angle. This side will be the opposite and this side will be the hypotenuse. So the two values I'm using is the adjacent and the opposite, which is this ratio. So I know I'm going to use tan theta equals the opposite over the adjacent. Obviously you don't have to write out the formula, but it's always helpful in case you kind of get stuck or muddled up because it is a really long question. So let's substitute what I know. I know that tan theta is going to be opposite, which is 9 over 15.23. And I'm not writing out all the decimals because it's saved in my calculator as the answer. And to work out theta, I am going to do shift tan on my calculator, 15.23. So shift tan, like that, it will appear, tan minus 1, and then you just put the fraction in, 9 over 15 oh, sorry, I had it saved as the answer. And you close the bracket. So remember that if you have whatever your last calculation was, that's the answer, so you can press the answer button instead of typing out all of the decimals again. And that gives me theta must be 30.577946 blah blah blah. It says give your answer correct to one decimal place, so that would be 30.6. Okay, so here we have a slightly complicated looking question with algebraic fractions, but remember fractions have the same rules whether they are simple fractions like 5/3 plus 2/5 or whether they're these complicated fractions, and that is that whenever I am adding or subtracting fractions, however complicated they may seem, I can only do so if they have the same denominator. Okay, so if you're adding or subtracting fractions, they need to have the same denominator, and that's the key thing here. So none of these currently have the same denominator, so I'm going to have to multiply through in order to do this. So let's write them out over here. And then let's see what we can do to manipulate these so that they have the same denominator. Now 1 is just going to be over 1 because any fraction, any number over 1, it turns itself into a fraction, because dividing by 1 it stays the same thing. So whenever you've got an algebraic fraction, generally your denominator is going to be the product of the two separate fractions. So what I want to do first is multiply by x plus 2. Okay, so this one already has a denominator of x plus 2, so I don't need to do anything to it. But here I'm going to need to multiply this fraction by x plus 2 and also the next fraction by x plus 2. And whenever you're multiplying fractions, in order to keep them in the same proportion, you need to multiply the numerator and the denominator. So that would become 2x plus 1, x plus 2, over x minus 2, x plus 2. And this would become just one lot of x plus 2 over x plus 2. Because obviously anything divided by itself is itself, so that's still 1, it's just written in a different expression. So I've done that first part, because this is the denominator that I'm after, x plus 2, x minus 2, so that everything can have the same denominator. It needs to be the lowest common multiple. It's algebra, so generally it's the product. So now I'm going to multiply everything by x minus 2. This fraction already has x minus 2 in its denominator, so I don't need to touch that. And this would become 3x, x minus 2, over x plus 2, x minus 2, minus 2x plus 1, x plus 2, over x minus 2, x plus 2, and this would just become x plus 2, x minus 2, over x plus 2, x minus 2. So it looks a lot more complicated now than it did originally, but the only way you can add or subtract fractions is if they have the same denominator. So this was a necessary evil in order for me to progress. So now that I have them all with the same denominator, what I can do is, first of all, it would probably help if I expanded the brackets just to simplify my numerators a bit. So that would become 3x squared, take 6x, and this, I'm going to put it in a bracket, would become 2x squared plus 4x plus x plus 2, and this over here would become x squared, take 2x plus 2x, take 4. Okay, so I can simplify these now, And that's just my numerator. My denominator is going to be x plus 2, x minus 2. So I've got 3x squared, take 6x, take 2x squared plus 5x plus 2, take x squared minus 4 over. Now, because I've already simplified this here, I know that this bracket, when I expand it out, is going to simplify to x squared minus 4. So I can just do that. And that's also the form that they want you to have it in as your final question. So all I've done is expanded out the brackets for the numerator and the denominator. Now I just need to simplify. So whenever you are dealing with terms being subtracted and there's more than one, sometimes people get very confused by this. So what you can do is you can just imagine there's an invisible 1 there, and you could expand the bracket like that to help you out. So you'd be left with 3x squared minus 6x minus 2x squared, minus 1 times 5 is minus 5x, minus 1 times 2 is minus 2, minus x squared, and then plus 4 over x squared minus 4. So let's see what we can simplify. We've got 3x squared minus 2x squared minus x squared. So 3 take 2 take 1 is 0. So they all cancel out. Then you've got minus 6x minus 5x. So minus 6 minus 5 is going to be minus 11x. Then you've got minus 2 plus 4. Minus 2 plus 4 is positive 2 over x squared minus 4. And that's how you do it. Now, normally it's nice for your numerator not to begin with a negative. So it could have been nice to write 2 minus 11x over x squared minus 4. However, they want your final answer to be written in the form ax plus b. So negative 11x is the coefficient of x. So you just leave it in that form. And that's that. Okay, so in this question, I'm told that the profit made by a shop increases each year. The profit made by the shop in year n is Pn. Given that the profit made by the shop in the next year is Pn plus 1, then Pn plus 1 equals APN plus 800, where A is a constant. The table shows the profit made by the shop in 2018 and 2019, and you are being asked to work out the profit predicted to be made in the shop in 2021. So the first step is we need to figure out what A is. So if I start with Pn, that would be 2018. Okay, so your first year. So Pn is like your original year. So if that's Pn, then Pn plus 1, which would be 2019's figure, must be 29,600. So I'm just Pn plus 1 is going to be whatever 2019 year's profit is, must equal APN. So Pn is the 2018 profit, which is 24,000. So I put A times 24,000 plus 800. Okay, and then all I need to do is just rearrange that to make A the subject and figure what it is. So first step, I'll subtract 800 from both sides. So 29,600 take away 800 gives you 28,800, and that's equal to A times by 24,000. So all I do is I divide both sides by 24,000 to figure out what A is. So 28,800 divided by 24,000 is 6/5, which is 1.2. So I know that A is 1.2, and now I have an equation, an iterative formula for working out any other year. So I know that Pn plus 1 equals 1.2 Pn plus 800. So now let's do it for the next few years. So for 2020, to work out 2020's profit, I'm going to put in 1.2 times by 2019's profit, which is 29,600 plus 800. And what does that give me? Well, 1.2 times by 29,600 plus 800 is 36,320. Oops, equals 36,320. So then what do I do to work out 2021's profit? I substitute in 2020's profit. So 1.2 times by 36,320 plus 800, which equals, so 1.2 times by 36,320 plus 800 is 44,384. So with iterative formulas, or all you're doing is you're using the previous year or the previous answer in order to work out your next answer. Okay, so here we've got a probability question. I'm told that Ray has 9 cards numbered 1 to 9. He takes at random 3 of these cards and he works out the sum of the numbers on the 3 cards and records the result. Work out the probability that the result is an even number. Okay, so this seems like quite a complicated question, but if we break it down and we just do the things that we already know how to do, it becomes a little bit more possible. So first of all, I know that I'm dealing with odd numbers and even numbers. So what would the probability of getting an odd number be? Well, I've got 1, 3, 5, 7, and 9. So I've got 5 out of the 9 cards are odd numbers. And then for even, I've got 2, 4, 6, and 8. So 4 out of the 9 are even. I know that I pull out 3 cards, so I could set up a probability tree for this. So I've got odd and even, odd and even, odd and even, and then odd, even, odd, even, odd, even, odd, and even. So now let's work out the probabilities of that. So the first card, the probability of it being odd is 5/9, and the probability of it being even is 4/9. Always double check that your branches sum to make 1, because then you know you've got them right. Then for all of my second branches, my denominator is going to be over 8 because I've taken a card out, so there are only going to be 8 cards left. So everything's going to be over 8. And let's have a look at what's happening. So if I've taken an odd card already, there's only going to be 4 odd cards left. Haven't used an even card, so that would still be 4 over 8. Double check it adds to 1. Yes, it does. If I've taken an even card, to then get an odd card would be 5 over 8. If I've already used an even card, then it's going to be 1 less, so 3 over 8. Once again, they sum to make 1. For the last little bit, so I've taken out 2 odd cards, so I'm only going to be left with 3 odd cards. Oops, and it's not going to be over 8, it's going to be over 7. All of your denominators for your last little bit are going to be over 7 because you've pulled out 2 cards already. So you've taken 2 odd cards, that means you're still left with 4 even cards. You've taken 1 odd, 1 even, so you would be left with 4 odd cards and 3 even cards. Double check, 4 plus 3 makes 7, so you know you've done it right. You've taken out an even and an odd, so you would have 4 odd ones left and you would have 3 even ones left. Once again, you've taken out 2 evens, so you would only be left, well, your odd ones wouldn't be affected, so that would be 5 and this would be 2. So you filled out your probability tree, so now we need to figure out which branches are going to give us an even result. So if I had odd, 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 let's just pick a random odd number. 3 plus 3 plus 3 is 9, so that gives me an odd result, so I do not use this branch. Next branch would be odd, odd, even, so let's say 3 plus 3 plus 2. 6 equals 8, which is even, so I do use this branch. So I could record them all over here, which routes I'm going to take. Odd, odd, even. Let's try the next route, odd, even, odd. So once again, let's say 3 plus 2 plus 3, that's 6, that's 8. So that works as well. Odd, even, even. So 3 plus 2 plus 2, that's 7. That does not work. if you had even, odd, odd, so let's say 2 plus 3 plus 3, that would be 8, so that route works. Then let's try even, odd, even. So 2 plus 3 plus 2 is 7, that does not work. Even, even, odd. Even 2 plus 2 plus 3, that's 7, so that does not work. And then your final one, 2 plus 2 plus 2, that gives you 6, so that route works. Okay, so you set up your probability tree. You all know how to do that, hopefully. So the first part is simple. It's just trying to understand what the question's asking you, and it's a little bit long-winded. So you know what routes that you can take. You can take odd, odd, even, odd, even, odd, even, odd, odd, or even, even, even. Sorry, I got distracted there by air. Right, so let's work this out. So for this route, we would do 5/9 times by 4/8 times by 4/7. Whenever you're working out probability, you always multiply when you go along the branches. Over here, I would have 5/9 times by 4/8 times by 4/7. Over here, I would have 4/9 times by, where am I going? Odd, 5/8 times by 4/7. And then on the last one, I would have 4/9 times by 3/8 times by 2/7. Okay, so you've worked out your probabilities. You can work out the final results, or you could just add them all in your calculator, which, I mean, but let's do it properly just so that you see. So 5/9 plus times 4/8 times by 4/7 is going to give you 10/63. This is going to be the same because it's the same denominators, 5 times 4 times 4, so that would be 10/63 as well. Is this the same? No, this is different. You've got, no, it's the same, so that would be 10/63. And then you've got, obviously you can do this, I'm just doing this because it's shortcut. So 4/9 times by 3/8 times by 2/7 gives you 1/21. So you could have just done this all in your calculator in one go. You choose whichever way works best for you. I've just shown you what they would sum to. So then we add all of these fractions together. So plus 10/63 plus 10/63 plus 10/63. I could have just simplified that to 30/63, but hey, I didn't. And your final answer would be 11/21. So the key bit with the probability trees is you multiply to go along the branches, but once you've got your probabilities, it could either be this, or this, or this, or this. So you add your probabilities at the end. So what I've done is I just did 10/63 plus 10/63 plus 10/63 plus 1/21 to get me 11/21. And I did it on a calculator, so it simplified it for me. So we made it to the last question, and this is a super fun question because it's about quadratic linear, solving quadratic simultaneous equations, which is super fun. So to begin with, we are told that L is the straight line with equation y equals 2x minus 5, and C is a graph with the equation y squared equals 6x squared, take 25x, take away 8. Now, using algebra, find the coordinates of the points of intersection of L and C. So really quickly, just to give you a quick overview, if we have just a general graph, I know that this is a quadratic, and what do all quadratic graphs look like? Roughly like that. Okay, they're symmetrical because a negative squared is the same as the positive squared, and a straight line looks roughly like that. Okay, so whenever I have a linear and a quadratic equation and I'm trying to solve them, so I'm trying to find their points of intersection, I know that they are going to have 2 points of intersection. So they're going to have an x and a y coordinate for here and an x and a y coordinate for here. So therefore, whenever you're solving or finding the points of intersection of a linear and a quadratic, you are going to have 4 solutions, 4 answers, 2 x values and 2 y values. So that's just to bear in mind. Now, the best way to solve linear quadratic equations is by plugging in the linear equation into the quadratic. So we are told that y equals 2x minus 5. So wherever I see y in this equation, I can replace that with 2x minus 5. So I could say 2x minus 5 squared equals 6x squared. Take 25x, take 8. And the reason I do this is because it then eliminates my y variable. So I'm only left with x's to deal with, and I can solve that. So let's first of all just expand this. So you'd be left with 2x times 2x is 4x squared. 2x times minus 5 is minus 10x. Minus 10x plus 25. So let's simplify that. That would be 4x squared, take 20x plus 25 must equal 6x squared, take 25x, take 8. All I've done is I've plugged in the linear into wherever y was. So instead of y squared, it's this, expanded it, and now made it equal. So now I've got a funky looking quadratic. The only way to solve a quadratic is to make it equal to 0. So get it in the form ax squared plus bx plus c equals 0. And then you can factorize it. So let's do this bit by bit. Let's first of all take 4x squared from both sides. So I'm left with minus 20x plus 25 equals 2x squared minus 25x minus 8. Then what can I do? I could add 20x to both sides. So I'm left with 25 equals 2x squared minus 25 plus 20 is going to give you, where's my pen gone? Minus 5x minus 8. And then lastly, you're going to subtract 25. So you're left with 0 equals 2x squared minus 5x minus 33. So I've got this in this form, 2x squared minus 5x minus 33 equals 0. And now I want to factorize it. Now you can do this however you want to. You can use the quadratic formula if you don't like factorizing. But I am just going to use the grid method because I feel like it's going to be a simple one to factorize. So I know that I'm in my brackets, I'm going to have 2x and x because, well, the coefficient of x squared is 2, and the only way to make 2 is by 1 multiplied by 2. So I can put 2x over here and x over here. I know that they have to multiply, whatever my other factors are, they have to multiply to make negative 33. And then over here, I know that these two must sum to make negative 5x. So what are the factors of 33? I could use 1 and 33, or 3 and 11. So now I need to think, and this is why this is such a cool method. You can use a pencil, try things out, rub it out, try the next thing. There's only 2 possible solutions really. So either I'm going to try 11 and 3, or I would have swapped them around and tried 3 and 11. So 2 times 11 is 22x. Oh, and one of them needs to be a negative. So let's say negative 11. So that'd be minus 22x. 3 times x is 3. So minus 22 plus 3 is minus 18. So it can't be that. So let's swap them around. And I will put 11 over here and 3. And then let's choose one to be negative. Well, let's multiply it first. So that would be 11x. That would be 6x. So how do they combine to make minus 5x? Well, if this was a minus 11 plus 6 is negative 5. So that's how I know that. So I then have my brackets. It would be 2x minus 1 and x plus 3 equals 0. So I factorized it. If you don't like that method, that's absolutely fine. Use the quadratic formula or any other way that you feel you want to use. So I've got 2x minus 11, x plus 3 equals 0. When I solve a quadratic, I'm going to first divide by this side. So I know that 2x minus 11 equals 0. So 2x is 11 and x is 11 over 2, which is 5.5. So I'm just going to write this over here. That's my first solution. I know that x is 5.5. Then I'm going to divide by the next bracket. So I'm going to divide by this. So I'll be left with x plus 3 equals 0. Therefore, x is negative 3. So my next solution is x is negative 3. Now this is the super fun part. Well, all of this is super fun, but this is the super nice part. Once you have found your solution for x, all you need to do is substitute into one of the equations to work out your y values. So when x is 5.5, y is 2 times 5.5, take 5. All I've done is I've substituted into this equation here because it's obviously like the simplest one. So y is 11 take 5, and 11 take 5 is 6. So when x is 5.5, y is 6. And then let's do it for when x is negative 3. Y is 2 lots of negative 3, take 5. So y is minus 6, take 5. So y is minus 11. And there we have it. We've got our two sets of coordinates. As you can see in your answer, you've been given two sets of coordinates. So we write it as this set, 5.5, 6, and negative 3, negative 11. And that's how you've solved your equations. So super simple, sort of plug the linear into the quadratic, expand and rearrange your quadratic so it's equal to 0, factorize it, get your solutions for x, then plug the solutions for x back into your linear equation, and then you've got your answer.